This is Mr. Beck Does Your Homework, AP Physics, Homework 7.2, questions 3 and 4. A circular swimming pool has a flat bottom and a 3.67 meter diameter. That's going to come into play. So here's my pool, and my diameter of that pool is 3.67 meters. It is filled with water to a depth of 1.48 meters. 1.48 meters is that. And there is 0.676 atmospheres of pressure at the top surface. So it's filled with water, and there is 0.676 atmospheres on the top surface. What is the absolute pressure at the bottom? Well, the absolute pressure at the bottom is going to have to do with the pressure due to the water plus the pressure due to the atmosphere. Now, I could find the pressure in the bottom equal to the force of gravity on all the water divided by the area of the bottom. But I don't have to do all that because I'm smart and I know that my pressure due to the water is going to be rho g h. It's going to be the density of the water times the gravity of 9.8 times the height, the depth of the water. It really doesn't matter how big this pool is because I'm going to do rho g h with that. But that's just from the water. I also have the pressure due to the atmosphere, and that's 0.676 atmospheres, and I know that 1 atmosphere is 101,300 pascals. So I have the water, rho gh, plus the atmosphere, and that's going to be 0.676 times my 101,300. So there is the air, and there is the water. They'll give me the rho gh. So my pressure is going to be the density of water. Since they don't tell me, I know that water is 1,000. Gravity is 9.8. The height is 1.48 plus my 0.676 and my 101,300. So that'll give me my absolute pressure at the bottom of the pool due to all of that. So that's the answer to number 3. Number 4 says 2 people with a combined mass of 60.7 kilograms get into the pool and float there quietly. What is the resulting increase in the absolute pressure at the bottom? Well, this is a little different because now these people are not infinite, so we can't worry about like how big that depth would be. But with those 2 people, they have a combined mass of 60.67 kilograms. Well, that's an additional force of 60.7 kilograms is going to be the mass times the gravity. That's going to be the weight of these people. But that weight, once they get in, actually they're going to get in, the water's going to go up ever so slightly, but that raise in the water is going to kind of distribute their mass over the entire bottom of the pool. So now my increase, I just want the increase in the pressure at the bottom. So my increase in the pressure is going to be my increase in force divided by the area. So that's going to be mg for the people divided by the area of the pool is going to be half the diameter squared, so that's r squared times pi, right? Pi r squared is going to give me the area at the bottom of the pool. So for me, this is going to be 60.7 times 9.8 divided by pi times 3.67 over 2, that's r squared. So that will give me the change in pressure at the bottom is this force distributed over this area.